Hello everyone, welcome back to Success Educational Consult. This is a continuation of what we did the last time we met. BECE Mathematics 2025, question number 3. Let's get into it. Question 3a says, given that the vector A has components 2 and 3, vector B has components x and negative 3, and vector C has components 7 and 3. Find I, the value of x, if 2a plus b equals c. I, d equals c minus 3a. I. The magnitude, that is the meaning of this symbol, the magnitude of the vector d, or the magnitude of d. Then we come to b. A polytank contains 4,500 liters of water, and one phase of the water is used for cleaning. I, find the volume of water used for cleaning. I, what percentage of water is left in the tank? Solution A. We've been given 3 vectors, A, B, and C, and we have to find the value of x. X belongs to vector B. That's the x component, this is the y component. So what do? According to the question, it says if 2a plus b equals c, 2a plus b equals c. What does this mean? We are multiplying the components of a by 2, adding it to the vector b, and then we equate it to the vector c. Now before I move on, vectors normally appear in BECE simply because candidates normally treat vectors as fractions. So examiners or WAEC is always bringing vectors so that students, sometimes it is used to test the intelligence of students. So when you see vectors are not fractions. Take note of that. You can use a fraction to multiply a vector. In that case, that fraction is called a scalar. That will be used to multiply the vector. But then vectors are not fractions. Let's go. So 2 multiplies the components of A, which are 2, 3, plus the components of B, which are x, negative 3. Then we equate this expression to the components of C, 7 and 3. Now with this, we need to expand what we have over here. So we use the 2 to multiply this 2 and the 3. You don't just use it to multiply the 2, no. Multiply it by the x component and the y component. So this is a scalar. This 2 is a scalar. So we use the scalar to multiply the various components. So 2 times 2 gives us 4. 2 times 3 gives us 6. So these are the new components of the expression 2a. After this, we equate corresponding components. When we say corresponding components, we have x components and y components. So we equate all the x components so we can find the value of x. So the components of x, we have 4 plus x equal to 7. This is our equation. Now in a linear equation like this, we know what to do. There are 2 ways of doing this. Either we use the balancing approach or grouping of like terms. So grouping of like terms, x is equal to 7 minus 4. A simple reason. 4 is positive on the left hand side of the equation, it becomes negative on the right hand side of the equation. In fact, this is not a conjured something. there is a reason why we are subtracting. When we use the balancing approach, let's try the balancing approach. We are eliminating 4. All right, we are eliminating 4, and we look at the state of this 4. It is positive. So what do we use to eliminate this 4? We use its opposite, which is -4. So it's going to be 4 minus 4 plus x equal to, because it's an equation, whatever happens on the left hand side also happens on the right hand side. So we have subtracted 4 on the left hand side. The same 4 must be taken away from the right hand side. This is the reason why we normally change the operational sign when we are putting the words when we are grouping items. When we are grouping items, because of the balancing approach. So the value of x is 3. Most of the times students would like to analyze this way. It doesn't make sense. It is not needed. It is not needed at all. So just leave your answer as it is and move on. Let's come to II. II says you should find the value of D, which is equal to C minus 3A. So let's move on. D is equal to, so this II. D is equal to C minus 3A. Now the components of C are 7, 3. Minus 3 multiplying the components of A. So 3 multiplying 2, 3. So that is the vector D. Now we are multiplying 3 by each component of the vector A. So minus 3 times 2 and 3 times 3. So that's it. Now let's move on. 7, 3 minus 6, 9. Now one may ask, won't this negative sign affect everything here? It is still there. The negative sign is still there. This is 3 multiplying these components, but then the negative sign is still there. Once you bring it over here, you will confuse yourself. So you leave it here because it is still affecting these components. Now subtracting corresponding components. 7 minus 6, 3 minus 9, and that gives us 1, -6. So that is the value of the vector D, 1, -6. Then we go to III. III says that we should find the magnitude or length or modulo. How do you find the magnitude of a vector? You will have time for vectors as a topic on its own, and then we will explain how to find the magnitude. But for the meantime, how do you find the magnitude of a vector? We use a formula. So the magnitude of the vector D is equal to the square root of x squared plus y squared. This has something to do with Pythagoras theorem, so take note of that. Now, what is x? When you check the components of the vector D, x is 1. So 1 squared plus y which is negative 6. Negative 6 squared. We are putting a negative 6 in a bracket so that the square affects everything, including the negative sign. Now the square of 1 is 1, and the square of negative 6 is 36. So finally, our magnitude of the vector D is 37 units. It doesn't have vectors, don't have units. So when you get a magnitude, you just add units to indicate that we are finding length or magnitude. So that is for question number 3A. The magnitude of the vector D is the square root of 37. Now 37 is a prime number. It doesn't have any factor which is a square number that we can expand and write them in sets. So this set remains the same. So the square root of 37 is units. We are good to go. Now we'll move to B, a polytank. I've read the question already, so let's go straight to the point. B. It says find the volume of water used for cleaning. 1/5 of the water is used for cleaning. Very simple. 1/5 of 4,500. So BI 1/5 times 4,500. So 5 divides itself once. The division is very, very important. If you don't do that, you'll be penalized when you are marking your BECE scripts. 5 divides 45, 9 times, add the zeros. So you have 900. Now you have 900 liters. You can decide to write it in full or 900 L. Once the unit is there, it doesn't matter. That is BI. II says what percentage of water is left in the tank? Percentage of water is left in the tank. We know how much water is used, 900 liters. So to get the percentage of water left in the tank, we need the water left first. So we need a volume of water left first. So the volume left, that is 4,500 minus 900. Now pay attention over here. When you are calculating something like this, don't just write the answer. I told you in our last meeting that your brain is your calculator. You are not allowed to use any calculator. So once your brain is your calculator, have time for your brain. Write this vertically. This way, and subtract it step by step. So 0, 0, 5 minus 9 is not possible. So we will borrow from here, leaving 3 here. When we add, now normally we say we borrow a 1. We don't just borrow a 1. Now the borrowing is determinant on the place value. We are borrowing from thousands. So it means we are borrowing 1,000, right? So we are having 1,500 minus 900, and that gives us what? 600. That gives us 600, or that gives us 6. That is 15 minus 9. If you say you are borrowing a 1, if you add 1 to 5, it is 6. So it wouldn't actually make sense. So when you are borrowing, you actually have to consider the place value you are borrowing from. So if you are borrowing from 1,000, it means you are borrowing 1,000. You are borrowing from thousands. So you are borrowing 1,000. You add it to the 500, making it 1,500. Take away 900 from 1,500, and we are getting 600. Then we are left with 3 over here, minus nothing. So we have our 3. So this is 3,600 liters of water left. After this, what do we need? We need the percentage of the water left, of the volume of water left. How do we find percentage? So percentage, anytime you have to find percentage of something, just multiply by 100. What are we multiplying by 100? We have the water left. So water left, or the volume left, over the total volume times 100%. So that will give us 3,600 over 4,500 times 100%. And there are so many ways of doing this. With your idea of division, you can decide to divide this 0 and this 0, this 0 and this 0. When you finish, you realize that 36 and 49 have something in common. The highest, 36 and 45. The highest common factor of 36 and 45 is 9. So we use 9 to divide 36 4 times. 9 divides 45 5 times. So we're going to have 4 times 100% all over 5. 5 is a factor of 100. So we use 5 to divide itself once. Then 5 divides 120 times, giving us 4 times 20%. So finally, the percentage volume of water left is 80%. 80% of the volume of water is left. This brings us to the end of today's episode. Thank you very much for watching. Don't forget to subscribe, like, and share. My name is Prosper. I've been your math facilitator. Bye-bye.